Today I will discuss Euclid's division algorithm. Before discussing Euclid's division algorithm, I want to discuss algorithm. That is, we have to know what algorithm means. Okay, algorithm. A step-by-step method. A step-by-step method. A step-by-step method used to solve a problem is called algorithm. Algorithm. Step-by-step method to solve a problem. That is, here we have to use many steps to find the solution of a problem. Just you take the case of a ladder. If we want to rise at the top of a building, we have to use the steps of the staircase of the building. Now, and you see each step is based on the previous step. Like this, here many steps we have to use, and each step is related with the previous step. So we call it step by step, because every step is dependent or related with the previous step. That is why we call it step by step. Okay. A step by step method used to solve a problem is called algorithm. Okay. Now Euclid's division algorithm. So Euclid's division algorithm, only Euclid's division, this is added with the algorithm. So Euclid's division algorithm is also an algorithm. But here in each step we use what? Euclid's division lemma. Okay. Since we use Euclid's division lemma in each step, so it is called Euclid's division algorithm. So it is also a step-by-step method used to solve a step-by-step method which uses Euclid's division lemma. Now in this method, in each step, what is used? Euclid's division lemma. Euclid's division lemma to solve a problem. Here to find the HCF of two integers. Okay. Euclid's division algorithm, a step-by-step method which uses Euclid's division lemma to find the HCF of two integers is called Euclid's division algorithm. Okay. So what is Euclid's division lemma? You have to know what is Euclid's division lemma. So to know Euclid's division lemma, you just watch my previous video, real number part 1, where regarding Euclid's division lemma I made the discussion. Okay. So you must see Euclid's division lemma to understand Euclid's division algorithm properly or immaculately. Okay. Now we will use Euclid's division lemma to find the HCF of two integers. So let us take, we have to find out the HCF of 90 and 135 using Euclid's division algorithm. Okay. So which is greater here? 135. So divide 135 by 90. Okay. 1. So 90. This is 45. Then by this 45 you divide this 90. What you get? 2. 90. 0, 0, 0, cipher. It is also called cipher. 0 is called also cipher. Okay. CYPH here, cipher. So you see, step 1. So 135 is equal to what we can write? 90 multiply 1, that's 45 is 135. Step 2. Second step, 90 45 multiply 2 plus 0. So you see here in this step we used Euclid's division lemma. Okay, so you have to learn lemma. For this you watch my previous video, real number part 1. Second step, this is Euclid's division lemma. Using 2 steps we have got the solution. Okay, so Euclid division algorithm we have used because we have used their first step and second step. Nah? So steps are used there. So division algorithm, Euclid division algorithm has been used to solve this problem. So this is the divisor, you see, this is the divisor, and when remainder is 0, then the divisor for this divisor remainder is 0, then this divisor is the highest common factor. Nah? This is remainder. So learn once more I am telling you, watch my previous video, lemma, Euclid's division lemma, then you will understand what this is. Okay, so this is remainder actually, this is remainder, this is divisor, this is quotient, nah? This is dividend. So this divisor when remainder is 0 is the HCF. So 45 is the HCF. This is our answer. Okay. Now one more question for you. Find the HCF of 60 and 80. 80 is greater than 60, so we divide 80 by 60. 160 minus 20. Again, this divisor should be divided by this remainder. 360. Okay. So in step 1, 80 is equal to 60 multiply 1 plus 20. Step 2, 60 is equal to 20 multiply 3 plus 0. So for this divisor remainder is 0, so this divisor is the HCF. So this is Euclid division algorithm. Okay, using this we have got the HCF of 2 numbers. So doing in this way, that means do this first and after that you write this and finally you write this answer. Nah? And if you don't do this one, if you don't do this one, only if you do this one, then also this is called Euclid division algorithm. Then also your problem will be, solution will be correct. Your solution will be palatable. Your solution will be acceptable. Okay. Because you see, this is the first step, again this is the second step, this is written in this way and this is written in this way. Okay. So if you don't do this one, only if you do this one, then also your answer will be correct. This is first step, this is second step. Now for this divisor remainder is 0, so this divisor is the HCF. Okay. So in this way you do yourself. Nah? I will give you convoluted problems, perplexing problems, critical problems afterwards. Nah? Now one question. Stay 18 Kaju Burfis and 36 Badam Burfis on a tray. This is a tray, on a tray like it. Suppose this one is tray. On a tray, so that each stake has equal and maximum number of Borfis. Find the number of Borfis in each stake and the number of stakes of Badam Borfis. Stake means what? One Borfi, then above this another Borfi, then on this above another Borfi, then on this another Borfi. So like this one stake. This is one stake, this is one stake, this is one stake. This is called stake. Na? One above the other, one above the other. Na? Stake. So like this you have to make the stake. Na? So 18 Kaju Borfis, 36 Badam Borfis. Na? Condition is what? Each stake should contain equal number of Borfis. So let me see. Let us make stakes. Okay. Suppose I take 3, na? 1, the 1 or 2. Okay. 2 Borfis in each stake. So if I take 2 Borfis in each stake, by 2 you divide this one. Yes, this is divisible by 2. That is, we will get how many stakes containing 2 Borfis each? 9 stake. Na? 9 stake. And again this is also that means 2 Borfis in each stake. Here also 2 Borfis should be in each stake, because condition is given, na, each stake should have equal number of Borfis. So 2 Borfis in each stake. So how many such stakes we will get from this 36 Borfis, Badam Borfis? 36 should be divided by 2, then 18. 18 stakes we will get. Okay. But condition is what? Maximum number of Borfis should be present in each stake. So let us see whether we can make maximum number of Borfis in each stake or not. If I take 3 Borfis in each stake, and we have to see whether by 3 this is divisible or not. If this is divisible, then yes, in each stake we can that means put 3 Borfis. Na? Yes, 3 Borfis. Then how many such stakes will get? 18 should be divided by 3. Okay, 6 stakes from this we will get. Now each stake contains 3 Borfis. And here also 3 Borfis should be present in stake. So by 3 this should also be divisible. So yes, this is divisible. 36 by 3 what? So we will get 12 stakes. Na? Let us see whether more number of Borfis may be put in each stake or not. If I take 4 Borfis in each stake, 4 Borfis, and you have to see whether this is divisible by 4 or not. No, it is not divisible by 4. So 4 Borfis is not possible. 5 Borfis you take, 5 Borfis. If I take 5 Borfis, then by 5 this should be divisible, not divisible. So 5 is not possible. 6 Borfis in each stake, 6 Borfis, 6 Borfis, and by 6, yes, this is divisible. Na? So how many stakes we will get? 6, 6, again 6, 3 stakes. And by 6 this should also be divisible, because here also in each stake there should be 6 Borfis. If I divide this by 6, then what will get? 6. Then you will get 6 stakes. Okay. So let us see whether in each stake more number of Borfis will come or not. Okay. If I take 7, by 7 it is not divisible, so we cannot take. 8 not divisible by 8, this is not divisible. 9, if I take 9, yes, this is divisible. So 9 Borfis can be put in each stake. Okay. So if I take 9 Borfis in each stake, then there will be 2 stakes from here. And by 9 this should be also divisible. Na? So in one stake 9 Borfis, so there if I divide this by 9, then you will get 4. So 4 such stakes will get. Okay. That is what we are watching. There is common factor. You see 9 is the common factor of 18 and 36, and this 9 is the number of Borfis in each stake. Okay, 9 is the common factor. So if I take the highest common factor of this and this, and that highest common factor is the maximum number of Borfis in each stake. Because 9 is the common factor of 18 and 13. So 9 is the number of Borfis in each stake. And we want maximum Borfis in each stake. So largest common factor of 18 and 36 is the maximum number of Borfis in each stake. That is highest common factor. highest common factor, that is largest common factor or highest common factor is our answer. Highest common factor is the number of Borfies in each stack, and then equal number of Borfies also in each stack. Na? So what we have to find? We have to find HCF. Na? I have explained this in detail for your comprehension, for your understanding. Na? Understood or not? That is, we have to find what? We have to find HCF of 18 and 36 to get maximum number of Borfies in each stack, and in such situation the number of Borfies in each stack also will be equal. So by using factorization method also you can find out the HCF, but here I am finding the HCF using division algorithm. 2z 36, remainder 0 we are getting na, so this divisor is the HCF. So HCF is 18 na, so 18 is the number of Borfies in each stack is equal to 18, and we have to find out what? Number of stacks of Badam Borfi. How many Badam Borfis are here? 18. In each stack, how many Badam Borfis are present? 18. So 36 should be divided by 18 to get the number of stacks of Badam Borfis. So number of stacks of Badam Borfis is equal to 36 by 18 is equal to. Okay. One more thing for your comprehension, that is understanding, I like to discuss here. Okay. If I take from here 3 Borfies in each, na? So 3 Borfies in each, that is one stack 3 Borfies, this much area, one stack occupy this much area from here. So how many such stacks from here we will get if each stack contains 3 Borfies? 6 stacks. So here we will give, put na 6 stacks, 1 stack, 2, 3, 4, 5, 6. So 6 stacks occupy this much area, and again from here if in each stack 3, then how many stacks will be formed from this 36 Borfies? 36 by 3, 12. So 1 stack, 2 stack, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This much area. So total this much area will be occupied by the Borfies here. Na? If in each stack 3 Borfies are present. Na? But if we want the Borfies to occupy minimum area, then maximum number of Borfies should be present in each stack. Na? That is, if 18 Borfies in one stack, then this much area, and from this 2 stacks we will get, if each stack contains 18, then one stack this much area, other stack this much area. Minimum area will be occupied by the Borfies. Na? Minimum area will be occupied by the Borfies if maximum number of Borfies are present in each stack. Okay, I think you have understood. Okay, so one more question. This question is from your book. A sweet seller has 420 Kaju Borfies and 130 Badam Borfies. She wants to stack them in such a way that each stack has same number and they occupy or they take up the least area. Just I have told. They will take up least area on the tray. Na? Least area of the tray. So when they will occupy least area? When in each stack maximum number of Borfies will be present. Na? That is a highest common factor of 420 and 130 you find out, and that highest common factor na will be the number of Borfies in each stack. Na? Maximum number of Borfies in each stack. So area occupied by the Borfies will be minimum. Na? Since given that the stake should occupy least area or minimum area of the tray. That is, we have to stake in this way, na? So that each stake contains maximum number of burpees, na? Maximum number of burpees. So what we have to find out? Find the number of burpees in each stake. That is highest common factor of 420 and 130. You find out. That highest common factor will be the maximum number of burpees in each stake. Na? That is number of burpees in each stake. So let us find out. 420 is greater than 130. So you divide this by 130. 3, 39. Na? Then it is 30. By 30 you divide 130. 4, 120. Then it is 10. By 10 you divide 30. 30, 0. So this is HCF. Remainder 0. So this divisor is the HCF. So number of burpees in each stake. Number of burpees in each stake is equal to 10. Okay. And also total number of stakes. You see, each stake contains 10. So how many stakes from 130 will get? 13 stake. And 420, each stake contains 10. So from 420, how many stakes will be formed? 42. So total number of stakes is equal to 130 by 10 plus 420 by 10. That is 1342, 55. Okay, I think you have understood. So you just try to do problems, different kinds of problems from your book. And one thing is here that you should clear your conception. You go to the root of mathematics. When you go to the root of mathematics and whenever you clear your conception, your passion will be developed on mathematics. You will start loving mathematics. And when you start loving mathematics, then you don't require to run after the marks in the examination. Marks will run after you. Okay. And this is my WhatsApp number 70022 This is my WhatsApp number. Okay. If you have any query, then you just send your query in my WhatsApp number. Okay. And gradually I will discuss convoluted questions. That means questions will be convoluted, question will be perplexing in metric examination. So there will be various types of questions in the metric examinations. Patterns will be changed. So you have to prep for the new pattern of questions. So you try to clear your conception. Okay. God bless you.